Let's draw the cone. And the height of the cone is 8 centimeter. We also given the radius of its top, which is open, is 5 centimeters. So you can see it's an open end here, and the radius of it is 5 centimeters. Now it is filled with water. So we can see that water is being filled in this. There goes the water, and after filling the water inside it to the brim, means it is completely filled up to the top with water. And after that, lead shots, spherical lead balls, each of which is a sphere of radius 0.5 centimeter. Now inside this, a spherical shell, large number of spherical shells are placed inside. The radius of the spherical shell is 0.5 centimeters. So when these spheres, lead shots, are put inside this conical container, then it is said that 1/4 of the water flows out. 1/4 of the volume of this water flows out of it. Okay, and we have to find the number of lead shots. So let's see. Solving the sum further, we have volume of n number of lead shots is equal to volume of cone, that is 1/4 of the water flows out, so that is equal to 1/4 the volume of the cone. Now placing the formula for it, we get n is number of lead shots. For sphere, the volume formula is 4/3 pi r cube. Okay, and then we have 1/4 into formula for volume of cone, 1/3 pi r square. Here if you see, this radius is for the radius of the spherical ball, let it be r2, and here 5 centimeter the radius for the cone, so let it be r1. Now let's try solving these values. We get n is equal to, let's write these values first, 1/4, or we make a big line, into 1/3 into r square, r1 square into h. Now this 3 will move on top, this r2 cube will move at the bottom, and 4 at the bottom. Now let's replace the values. You can see r1 is 5, so 1 1 the 1, you get 5 into 5. The height of the cone is 8 into 3 upon 4 into 3. The radius of the cone, as you can see, 0.5. So if I add 1/2 here, that 2 goes on top and 1 comes down, into 1 into 1. So it's 3 times, no? So you write 2 3 times here, and lastly take 4. You can see this cancels. Okay, and even this cancels. 4 2s are 3 and 3 cancels. 5 is 25, 20 50, 52s are 100. So number of lead shots. In the last line you can write the number of lead shots placed in the vessel or immersed or dropped in the vessel is equal to, in exercise 13.2 in question number 6, we are given that a solid iron pole consists of a cylinder of height 220 centimeter. So we are given a longer cylinder. We can consider its height as h1, 220 centimeter, and it's given that its diameter is 24 centimeters. So the diameter is 24, and obviously the radius of it will be 24/2, which is equal to 12 centimeters. Right. We also given it is surmounted by, it means above it has another cylinder of height 60 centimeter. We'll draw the other cylinder with a dotted line. You can consider the height of it as h2, we are also given in the question that the radius of it is 8 centimeter. So R2 is 8 centimeters. Now what are we supposed to find? Here in this we are supposed to find the mass of the total iron that is used in it. Okay, it is given that 1 centimeter cube of iron has approximately 8 gram of mass. The value of pi is given to us. So first of all we will find the volume of solid is equal to the volume of lower cylinder plus volume of upper cylinder. So lower cylinder we can take as pi R1 square H1 plus pi R2 square H2. Taking pi common from both, we get R1 square H1 plus R2 square H2. As the value of pi is given to us, we will consider as 3.14. As far as R1 is concerned, we will take the value as 12 whole square into height of the lower cylinder 220 plus radius of the upper cylinder, that is 8 square, and height of the upper cylinder 60. On evaluating all the values in the bracket, you will get the answer as 35520 centimeter cube. Now it is given that mass of 1 gram iron is taken as 8 grams. Let's find this in kg. So you divide this by 1000, you get the answer as 0.008 kgs. Further you can write, therefore, mass of this one, write this value here, 3.14 into 35520 centimeter cube of iron is equal to question mark, multiply this value with 0.008, and in the end you get the answer as 892.26 kgs approximately. So in the end you can write the statement, thus the mass of the pole is 892.26 kgs. Moving to question number 7. In this we are given a solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere. So first we will draw the hemisphere. Okay, above this we have a cone. We can draw this with a dotted line to mark the difference between the solids. That's a cone. It's a hemisphere. Okay. The measurements are given to us. This will be the radius. So the radius of cone and radius of hemisphere are going to be the same. If you see here, the height of the cone is given as 120. H1 is equal to 120 centimeter, and also it is given the radius is 60 centimeter. R1 is equal to 60 centimeter. Now it is given further in the question that given the radius of the hemisphere is 60, okay, is placed upright in a right circular cylinder filled up with water. This combined solid is put inside a cylinder. And this cylinder is completely filled with water. Now we have to find out how much water comes out of it. Okay, the measurement of the cylinder is also given. It is given that the radius of the cylinder is 60. It means the radius of all the combined solid as well as the cylinder is same. And it is given that the height of the cylinder is 180. H2 is equal to 180 centimeters. Right? So we are supposed to find, so in one straight line I write the formula of height of water replaced or volume of water left in cylinder. So you write like this, volume of water left in the cylinder is equal to, so you can see here, first you will take the volume of the outer cylinder, so you write there, is equal to the volume of cylinder minus volume of combined solid. So for formula for volume of cylinder is pi r. As you can see here, the radius for the cylinder is also 60. So I consider R2 for the radius. R2 H2 pi r square H2 minus. As it is a combined solid, as you can see here, in a combined solid we have a cone. So the formula here for it will be 1 upon 3 pi R1 square H1 plus the volume for the hemisphere is given as 2 upon 3 pi R1 cube. Placing the values in this formula, we need not take anything common outside. We will try to solve it directly. Okay. So what else do we get here? We will place the values. So placing the values, if we see, then we get the values as leave pi as it is because the value of pi is not given in the question. So we will take the value as 22 upon 7 into the radius of the cylinder is 60 into 60. The height of cylinder is 180 minus in bracket 1 upon 3, okay, into 22 upon 7. Radius of the cone is given as 60 into 60 into height of cone is 120 plus 2 upon 3. I'll write the remaining values here. 22 upon 7 into R cube means 60 into 60 into 60. So first we have to solve all the values inside the bracket. You see a plus sign here. Once you multiply everything out here, cancel and everything, then you find the LCM. And after finding the LCM, you get the values from outside the bracket. Okay, and when you get the value outside the bracket, you will get the answer on top as for the first value here, for volume of cylinder, you will get the answer as 22 upon 7 into 60 into 60 into 180 minus 22 upon 7 into 60 into 60, and once you further solve the remaining values in the bracket, you get the answer as 240. So first you solve this, then you solve that and subtract both the values, and when you subtract both the values, you get the answer as far as I suppose, you will get the answer as 1.13 meter cube. Actually, you should get the answer in centimeter cube here. So when you got the answer in centimeter cube, you will take that value and divide it by 1 and almost 6 zeros under that. Alright, so in the end you can write the volume of the water left in the cylinder is 1.131 meter cube. Moving to question number 8, we are given that a spherical glass vessel has a cylindrical neck. So draw the spherical glass vessel first. Okay, and then we have the cylindrical neck of it. So we will draw the cylindrical neck with a dotted line. What is given to us? We are given here that cylindrical neck 8 cm long. The height of the cylinder is 8 cm. And also we are given that the radius is 2 cm in diameter. So the radius of the cylindrical end is diameter is 2. So 2 upon 2, the radius will be 1 cm. It is also given in the question that the diameter of the spherical part is 8.5. So radius of the spherical part, just consider as R2. It will be 8.5 upon 2. Further solving, you get 85 upon 20. So cancelling by table of 5, you get 17 upon 4. This will be the radius of it. And now we are supposed to find, by measuring the amount of water it holds, a child finds the volume to be 345. We have to check whether the volume obtained by the child is right or wrong. They are given the value of pi as 3.14. So first of all, we will find the volume of the glass vessel. Volume of vessel is equal to volume of cylinder plus volume of sphere. For spherical part you can write here. Volume of cylinder is given as pi r1, as you can see here, r1 square h plus the volume of the sphere is given by the formula 4 upon 3 pi r2 cube. You can see here, right? We see that all the values are different. The only thing that can be taken common out from both the values is pi. So we will take pi common. We are left with r1 square h plus 4 upon 3 r2 cube. So the values, let's place the value 3.14 into in bracket. The value of r1 is 1 into 1. Height of the cylindrical part is 8 plus 4 upon 3 into r2 cube means 17 upon 4. So we write as 17 upon 4, 17 upon 4, 17 upon 4. First solve these values. They will be in fraction. You have a plus sign here. Then take the LCM. And once you take the LCM, in the last line from the bracket, you will land up on the value as 110.35. 110.354. Multiplying these two values in the end, you will get the answer as 346.51 centimeter cube approximately. So in the last line you write the statement. The child had got the value of 345. Okay, and we acquire the value of 346.51. So we'll write it as the child is not correct as per the observation because the actual volume is 346.51 centimeter cube. This marks the end of the exercise.